Let's take a look at 1.7 selecting procedures for finding limits. So remember, when you go to find a limit, the first thing that you're always going to want to try is direct substitution, right? Just take the value that your x value is approaching, such as 5 here, and you want to substitute it into that expression, right? Or that function, whatever the case is. And if that doesn't work out for you, if you get something that's undefined, for example, right, something where you're dividing by 0, that happens a lot, then you're going to want to find a different method, right? Some way to simplify or change how your fraction, for example, looks in order to actually find the limit by direct substitution a different way. Okay, so when we look at number 1 here, right, first thing I would want to do is direct substitute. Well, I can already see there's an issue. If I take my value of 5 and I substitute that for x, I'm going to get a 0 in my denominator. And if that happens, then that value is undefined. So that limit, that's not going to help me find the limit, right? And so let's just kind of ignore that. And remember, try to avoid putting like equals, you know, something 0 over 0, for example. Avoid doing that, please, because that doesn't really make sense. And the AP Calculus people are not going to like that, okay? So instead, let's take a look at how I could simplify this. The only thing I see, because I can't like really factor or anything like that, the only thing I see that I could do here is maybe rationalize this numerator, okay? That's something that we do in like algebra 2, right? So rationalize that numerator, and if I do that, then maybe things will simplify and I'll be able to substitute after that. So rationalizing that means to take basically the exact same expression, right? But you want to take the expression such that you have the square root of x plus 4 plus 3, right? You basically want to do a difference of squares type situation, right? That's what you want to end up with. So we're going to multiply by the square root of x plus 4 plus 3, okay? It's called a conjugate. And then same thing in the denominator. And this will allow us to simplify, and hopefully that will lead us in the right direction, okay? And so what we're going to do is we're just going to multiply the numerator. So square root of x plus 4 times square root of x plus 4 is just going to give us x plus 4. And then the two middle terms are going to end up being 0, right? Because we're going to add 3 square root of x plus 4 and subtract 3 square root of x plus 4. That ends up being 0. All we need to worry about then is just the numbers at the end, right? -3 times +3, and that's going to be -9. For the denominator, we're going to end up with something a little weird. So I'm actually just going to leave them as 2 separate binomials for now. I'm going to leave it as x minus 5 multiplied to the square root of x plus 4 plus 3. I'm going to go ahead and leave it that way because I might not need to simplify it at all. So let's take a look. That's still a limit as x goes to 5. Okay, so make sure that you write that as well. I can definitely simplify the numerator, right? And so that's still going to be a limit as x goes to 5. But the numerator is going to be x minus 5. And again, I'm not going to multiply the denominator out because I don't think I'm going to have to. And I don't want to make my life harder than it has to be. So let's go ahead and leave those as 2 separate binomials. Now what I see is because I'm multiplying x minus 5 times that square root x plus 4 plus 3 in the denominator, and I have x minus 5 in the numerator, I can actually go ahead and divide the x minus 5s to 1. That leaves me with just a limit as x goes to 5 of 1 in the numerator over the square root of x plus 4 plus 3 in the denominator. Now if I try to direct substitute, right, my 5 in, let's see what happens. We get 1 over square root of 5 plus 4 plus 3, and that's 1 over square root of 9, which is 3 plus 3, and we end up with 1/6. Okay, and so that actually worked out really well for us. We were able to simplify or change the way that this original expression, this rational expression looked, right, in order to create a fraction or an expression that looks different, right? And now when I direct substitute, I don't end up with something weird like a 0 in the denominator. Okay, so I would pause the video, try number 2, and then jump back into the video, and I'll show you what the answer to 2 is. So here's the answer for number 2. So taking a look at this, the first thing I noticed was that if I try to direct substitute in the denominator, I end up with 3 minus 3, which is 0, and so that's not going to work, right? And so instead I noticed that I could multiply by the conjugate, right? The conjugate of 3 minus the square root of x minus 1 is 3 plus the square root of x minus 1. And so I multiply numerator and denominator, by that. And again, I multiply, but I don't need to simplify when I multiply the numerator, those 2 parts in the numerator, right? I can just leave it like that. And then I notice that if I do some simplifying in the denominator, I can actually end up dividing a 1, right? X minus 10 and x minus 10, I can get rid of those. I end up with just a negative and then 3 plus the square root of x minus 1. And so then I just direct substitute at that point and I get negative 6. Let's take a look at number 3. So we have the limit as x goes to 0 of this expression. And when we look at this expression, if we were to put 0 in the denominator, right, what would happen is we would have 1 over negative 4 plus 1 over 4, and that's 0. When we have 0 in the denominator, right, when we direct substitute, we've got to try something else. And so what I notice is really the only thing I can do here is try to get rid of the fraction in the fraction. Somehow try to simplify so that we don't have a fraction in the denominator, and hopefully that'll allow us to direct substitute that 0 in and find this limit afterwards. There's a few ways to do this. I'm just going to go ahead and show you the way that I think is probably the easiest and where you'd be less likely to make some kind of mistake and mess up when you're simplifying, okay? And so all I really need you to do is look at the GCF of x minus 4 and 4. Okay, the denominators of those smaller fractions. And that's going to be 4 times x minus 4, right? And I want you to multiply both parts of your fraction by that. So I want you to multiply the numerator by that GCF, which is 4 times x minus 4. And then I want you to multiply the denominator by it as well. But when you multiply the denominator by it, you're really just multiplying the numerator of those fractions. So you're multiplying by 4 and x minus 4 to the first fraction, and same thing for the second fraction. Okay, it looks a little bit chaotic here for a second, but it's going to simplify really nicely. And so then what do we have? We have the limit as x goes to 0. And we have in the numerator, I'm not going to multiply it out for now. I'm just going to leave it separate because I might not need to. So I'm going to have x. I can go ahead and write it as probably 4x. So 4x times x minus 4. Go ahead and leave it like that for now. And then in the denominator, I'm going to go ahead and write it as, so if I have x minus 4 in the numerator and denominator, those are going to become a 1. Ignore them. I just have a 4 there. And then plus, and then I have 4 over 4 is 1, and I just have 1 times x minus 4. So x minus 4. And then let's go ahead and simplify the denominator because that looks like it simplifies very nicely. So the limit as x goes to 0 of 4x times x minus 4 in the numerator over 4 plus x minus 4, which is just x, right? And then what I notice is that x over x is 1. Since everything in the numerator is multiplied, well, by everything, let me just make sure that I'm clarifying. 4 times x times the quantity x minus 4, right? Since those separate parts are multiplied, x over x is 1, okay? X over x is 1. And so then what I'm going to have here is I'm going to have the limit as x goes to 0 of 4 times 0 minus 4, or 4 times x minus 4. And then I can direct substitute. I don't even have a fraction anymore. And so that's going to be 4 times 0 minus 4, which is going to be negative 16. And so that limit ends up being negative 16 for that one after we direct substitute once we simplify. So let's take a look at the next one. Again, I want you to think about the fact that when you have a fraction and a fraction, try to find a way to find the GCF, okay, of the smaller fractions. And then when you multiply that, the common factor here is always going to become 1, right, and cancel. So then you end up with just an expression, in this case in the denominator, and you don't have fractions anymore. So now I want you to look at number 4, try number 4, and then jump back into the video, and then you can see how I did it. All right, so for number 4, take a look at how I did it. So first I noticed that if I were to direct substitute 0, I would have 0 in the denominator. That's no good. And so what I saw is that I could probably really easily, not easily, but I could in just a few steps go ahead and get rid of the fraction in the fraction, right? Get rid of these. The GCF of x plus 3 quantity squared and 9 is just 9 times x plus 3 quantity squared. And then what happens there is x plus 3 squared, that's going to divide to 1, and then 9, right? Those are going to divide to 1, cancel, right, if you will. And then I just end up with 9 times 1 here in the numerator minus, be careful here though, minus, and then it's going to be just x plus 3 squared here. And so simplify very carefully. It's 9, and then I actually did go ahead and multiply this out because I was like, ooh, if anything's going to end up dividing to 1 or canceling, right, I'm going to need to simplify the numerator. And so I did. So I multiplied this out. I got x squared plus 6x plus 9, and then I did 9 minus that, so I went ahead and changed all the signs, right? And then I noticed that I could simplify this to basically negative x squared minus 6x, right, because the other 9 minus 9 is 0. And then I factored out just the x. I could have taken the negative x out, but I just took the x out right? And then I could just go ahead and divide x over x to 1 and kind of cancel it. And then once I did that, I realized that if I direct substitute 0, I don't have a 0 in the numerator or denominator, okay? I was able to substitute at that point and end up with negative 6 over 9 times 9. And then I actually simplified it ahead of time. I actually got rid of a factor of 3 there, and then I ended up with negative 2 over 27. So just keep in mind, whenever you're going to do these limits, right? If you direct substitute and you get a nice pretty number, that's your limit. But if you direct substitute and you get something like a 0 in the denominator, okay, things that are undefined numbers basically, then you want to try something else. Try to simplify things like multiplying by the conjugate like we did in the first two, or trying to get rid of fractions instead of fractions by simplifying. Here we multiplied by the GCF of the denominators. Anything that you can do to try to change the way that your expression looks so that you can direct substitute. All right, thanks for watching, everybody. Have a great day.